quite as exciting as being in class, but at least it hopefully will bridge anything that was missed so you could take that opportunity. So I am on page 165, and I just wanted to kind of go through some stuff. So at the top of this, what's up, Swanee? So on this page, it talks about there's some sort of period from January of 2002 to January 2014. Unemployment rate, or employment rate, unemployment rate, and then underemployment rate, which I'm not quite sure what that is, but so it says create a time plot for the unemployment rate, label the axis. All right, so I'm going to go in to the graphing calculator, and again, friends, if you ever need help on the graphing calculator, please just ask, and that includes in any tests and quizzes. So all right, so I'm going to start from the bottom of the list and go up. And being that this is a time plot, I don't have to have 2002, 2003, 2004, 2005, etc. I can, but that sometimes becomes extra information. So it's up to you how you want to set your data up. So I'm just going to use the 14, 13, 12, 11 on the x-axis, or list 1. So 14, 13, 12, 11, 10, 9, 8, 7, 6, 5, 4, 3, and 2002. Okay, does that make sense how I just plugged it in? And then create a time plot for the unemployment rate. So 92.5, these are percents. Unemployment rate. Oh, I'm sorry, I went to the employment. So 7.5, 7.1, 7.2, 7.4. 7.3, 7.7. 7.4, 7.8. 8.1, 11.3. Wow, 11.3. Jeez. 11. 10.6. And 10.3. Good, my rows lined up. I believe I have it in there correctly. So it says create a scatter plot. What'd I do? I did. I made a mistake. Is that supposed to be a 7.3? Yes, yes. Okay, thank you. That would definitely be an outlier. And my gosh, I hope we don't ever get to 73% unemployment rate. All right, so the data is plugged in, and I'm on page 165 in the book. I'm just reviewing for it. Did you want a note card for playing, jotting anything down for on the quiz on Thursday? All right, if not, you can keep the note card and make an airplane with it. All right, so create a scatter plot, label the axis. So the axes, if you created it, is the year, and then your y-axis would be your unemployment rate. So from there, a few things go in. Make sure you don't have that. Make sure your plot is on scatter plot, list 1, list 2. I'm looking good. And then you just go to zoom stat or zoom number 9. Wow. Do I have that plugged in right? That looks a little weird. I'm just going to go back to my stats just to make sure. Okay, someone verify for me. 14.7.5, 13.7.1, 12.7.2, 1174, 1073, 977, 874, 778, 681, 5113, 411, 3 10.6, 2 10.3. Does that seem what's on there? Okay, cool. So what do you notice when you just kind of look at it? Like this right here seems to be nice linear data. But this right here, so this is 2002, 2003, 2004, 2005, and then does this. So it could lead to multiple discussions of if this really was the rates, what was happening in 2002, 3, 4, and 5 that created such unemployment rates? What happened in 2006 to drop it down, roughly 3%? Yeah, there's all kinds of things that do take place in life. And the unfortunate thing is there are times when people might, not have a job. I mean, criminy, we had this whole COVID thing that unfortunately people had gotten misplaced. We don't have data for this year, but so there are things that we could do. Let's see. In a couple sentences, describe the time plot in the context. You would include comments about increase and decrease as well as changes in variability. So maybe comment about 2002, 3, 4, and 5. Those might be something different where we created a new trend up to 2014. Of course, we're in 2021 now, so we still have, many years that we don't know. Of course, we could look that up and continue, but if you were just to extrapolate off of the first 4 years from 2002 to 2005, that seems like unemployment's going up. But I have some questions for you as far as this goes. Though this looks like a positive trend, and this seems to be, it's decreasing, are these values on the y-axis large values? We can change what our data looks like just by changing our axes or changing where our graph is. So there's just some things that you could talk about. Talk about in those first 4 years, and then the next many years, the next 10 years. Is the data good, bad, indifferent? Can we really base conclusions on it? I would say we would want a lot more data than this. And of course, if we go in and look at things, use your calculator to create a regression line for this data. Include the variables in your equation. So if I do a linear line of best fit, it's number 8. I want list 1, list 2. So the line of best fit claims it is a negative, it's got a negative slope to it. We have a slope of negative 0.34 or negative 0.35 when we run 2 decimals. We have an R value of negative 0.83. So we have a relatively good regression line based on our equation. But that kind of seems a little obscure. Seems a little obscure when you look at it. So y equals 11.23 or 28, excuse me. X or no x plus negative 0.35. So friends, answer this for me. That R value is 83. That's like getting an 83% on a test, which is pretty good. But when you look at our data, it doesn't seem to match up what your thinking is. But really the reason that takes place is you're talking about values that are apart by, what's the lowest unemployment rate? 7.1, and the highest is 11.3. So from 7 to 11, you're not talking about a huge amount of money or a huge amount of unemployment. You go into y equals vars, statistics, and then over to equation. You can plot that. You can plot it and take a look at it. And that looks like a pretty horrible line of best fit. But it still had a 0.83, negative 0.83 R value. But again, it has to do with how close our vertical numbers are, how close our horizontal numbers are. Okay, this would look a lot different if we were to go, okay, let's go from 1900 through 2021. What is this going to look like? We have more data. We see some trends. There are times that there's times of war. There's times there's recessions. There's times that of just normal. So, you know, what is good? What is bad? I don't know. Let's see what the next thing is. So your calculator. What does the slope of this equation tell you about the change in unemployment over time? Explained briefly. Okay, so let's go back to here. So problem number 4, it wants to know what our slope really says, which this is negative 0.35. Okay, so this is a negative slope. This means that we have a decrease in unemployment. Okay, so what does it really mean? We drop negative 0.35 percent unemployment. It's unemployment each year. Okay, is that a trend that's going to stay forever? Again, we don't see what's happening from 15 to 21, but if we were able to keep this model, a couple things that'll take place. One, we would get to an unemployment rate that could be 0 based on our model. Okay, would that ever happen? I don't know. In a perfect society, maybe, but I don't know. What does the y-intercept convey useful information in this data? Rats? So y-intercept here, if we were to go into our second table, our y-intercept is 11.28, which we know is here. So does that mean that at 2001, our unemployment rate was 11.3? I don't know. I mean, it's an extrapolated thing, but we can't always trust it. So so our answer for number 5, 2001, because that would be our 0 mark, would have an unemployment rate of 11.3. Could we easily prove or disprove the 11.28? I think we could. So number 5, 0, 11.28, which this refers to the year 2001. This was the unemployment based on it when we're extrapolating. I bet you we have some useful devices that we all carry around that we could find out what the unemployment rate in 2001 was. Somebody with a phone asks Siri, what was the United States unemployment rate in 2001? Where is my phone? My phone's in my pocket. What was the unemployment rate for the United States in 2001? How much?
4.20.
As of 2013, the unemployment rate of United States.
I don't want that. What did you say?
4.20%.
4.20.
20.
Okay. So, trusting our phones getting 4.20%, they're claiming because when we extrapolate 11.28. That's a significant change. Okay? So, should we trust our model or not? Well, being we were able to disprove it the year before just by looking it up, that's one reason why you don't want to always trust extrapolation. Okay? Use this regression model to predict the unemployment rate in 2016. How about 2050? Okay. So I'm going to go back. I'm going to go back to our calculator. Go back to my graph. I'm going to zoom out because now we're really extrapolating. Okay? So 2016 means I'm going to change my I'm going to check for a value. I'm going to go second, calculate. I want a value at 16. So at 16, that's claiming that we have a 5.75% unemployment rate. Let's go to the phone. Find out what the unemployment rate was in 2016. Anybody. I don't care who it is. You could talk to your phone if you want to. 2016. 4.8? Wow. Okay, so we showed a downward trend for 2016. But then it says, how about 2050? 2050 hasn't happened yet. We don't have Siri to rely on. Okay, so again, if I go second, calculate, and I want to find a value, and I want to plug 50 in for 2050, 2050 means we have an unemployment rate of -6. Yeah. You could have. Yeah. So when I'm doing calculate the x value, that's basically subbing in this x right here, and it'll totally work for you the same way that we're doing. Now, the calculator is going to give it a little bit slightly different number because we rounded to 2 decimal places on this, and on the calculator it took it out a lot of decimal places, right? And I know that. That's not something where it's like, no, you're saying -6 based on the calculator. The person next to you plugged it in the calculator, you got -5.9999. You're both right. Okay? So, there are definitely things to do. I mean, I guess in 2050, which, let's see, 2050, Stirp's going to be old. Man. How old will I be in 2050? I'll be 80. Come see me. I might not recognize you. All right. Let's see. Use the same information from the previous page. I'm on problem number 7 on page 166. How much do we trust? How much trust do we have in the prediction in problem number 6? Well, it seems kind of ridiculous that we have an unemployment rate of -6%. Okay, that means 10-year-olds are back in the workforce because there's so many jobs. Okay, calculate the residual for 2008. Ooh, residual for 2008. How do we do the residual for 2008? This is problem number 8. And this is definitely a good one to look at. So our data for 2008, we have that 2008. (2008) 7.4. Okay, so again, I'm going to use my equation that we have here. I have 11.28 minus 0.35x. All right, so this is what our data shows us. Okay? Now, if I wanted to figure out what the residual was, I'm going to take this 8 and I'm going to plug it in. Does somebody have a calculator that they can do this so I don't have to jump back to mine? Just go 11.28 minus 0.35 times 8. 8.48. Okay? Help me out. Help me out, because I just don't remember off the top of my head. So with our line of best fit, at 2008, we have this. But if I plugged in this, this would fall here. So the distance here is the residual. So it had to be positive if it was above our line, agreed? So how do I make this positive? Okay, if I can't remember the equation, how do I make the distance from 8.48 to 7.4 positive? Well, I just go 8.48 minus 7.4. Help me out. 8.48 minus 7.4. So it has a positive 1.08 residual. Okay? So our data showed a certain line of best fit. If we wanted to take our equation and plug into that, we could determine that 2008 might have been an overestimate. Okay? Explain what the residual tells you in the context of the problem. Well, we have a positive residual value of 1.08. We overestimated. Or our linear equation that we had done by our data underestimated what actually happened there. So there's two different things that take place. Create the residual plot on your calculator. Does this show random scatter points, or does it appear to have a pattern? All right. So there was a place to find the residual value, and I have to flip back in the notes to verify how to find that residual value. Does anyone remember? But sure, if you're the one with the calculator. Huh? That you always remember it. I remember I have a whole bunch of useless knowledge that sticks with me. Let's see, residual plots. Predicted versus actual. Oh, there it is. You can find the residual, press enter. Okay, so the calculator calculates the residual every time you use the linear regression function. The calculator stores these residual values in a list called RESID. This list can be found using second list. All right, so second list. Oh, number 7. Oops, clear. Second list residual here. That's great. It points it here. And now here's something you can do. You hit store, and I'm going to put this into list 3. Okay? So if I go back to stat, under edit, then I have all my residual values there, and I can say this. Second stat plot, number 1. And I'm going to go down to list 1 and list 3. So I'm going to graph originally. I'm going to hit zoom in. So what do you think, friends? Is there some sort of pattern down here? It just means that all these values here have a negative residual value. Now, we found the one that we plugged in was positive. Okay, so these are just distances from it. What does it tell us about the model? Seems our residuals are all low on that. Why are we a little bit different? Well, one, the calculator has a much bigger than 2 decimal places plugged in, so there's a whole lot there. Linear regression information for predicting, I'm down on bottom page 166, predicting the amount of decrease in patient blood pressure from the dosage of a new medication designed to lower blood pressure is described as. So you have y hat, meaning we got that from data. There's a linear equation. Y hat is the predicted drop in blood pressure. X is the dosage of the new medication. And you have an R value of 0.794. Okay, so calculate the residual at 150. Okay, let's go with this. I'm going to go stat plot. I'm going to turn my plot off. I'm going to plug this in. Let's clear that. 22.25624 minus 0.026551 x. Okay, and I'm going to graph that. I'm going to go zoom fit, which is zoom 0. So this is our linear equation that's on that. So we want to see, calculate the residual for a person who took a 150 milligram dose of the resultant. So I can do a couple of things. I can go back to my table. Second table. And I can go down to 150. Is it going to let me do this? Nope. Okay. Thank you, Mr. Anderson, for giving us 150. This might go into second period. Almost there. Oh, stop, stop, stop. That didn't hear me. So 150. So this was what our data would have shown. 18. 150, 18.274. Okay. This is from our line of best fit. Okay. So if I take my equation, y hat equals 22.25624 minus 0.026551, and I plug in times 150. Someone do that on a calculator for me quickly. 18.273. So this is, if I go 18.274 minus 18.273, I'll wind up with 0.001. Okay? And I guess that was actually below, so it should be a negative value. It should have been this. Sorry, I went out of order. So, pretty good residual. Yeah, it's barely below the line. That's okay. You're a patient receiving this medication. Would a positive or negative residual be more beneficial? I would say negative. That means that your if blood pressure is on the y-axis, if you get if you take the medication and you're actually below it, you're a really good thing. Now, where some of these things took place, we all agree. COVID was a brand new thing. Yes, COVID viruses have been around forever. That's the common cold. But the particular COVID that came out, so I went and got, my vaccines. I have not gotten my third one. I'll get that. But, and that's just me personally. I'm not trying to influence or impact. So 48 hours, almost to the minute after my second vaccine, my fever spiked to 103. I felt like Dookie. Okay, so from 2:30 till 10 o'clock at night, I had 103 fever. I was like, actually got onto the thing, put in for a sub, contacted my department coordinator. Dude, I have 103 fever. This is bad. I feel like I'm gonna croak. And so he said, get a sub. I go to sleep. I wake up at 4. I felt like $1 million. I felt great. Canceled my sub, came to school the next day. I hadn't taken anything. My fever was there. I contacted the nurses line that they said on COVID. They said, oh, it's a side effect. It's okay. Next day, 103 fever again from 2:30 to 10 o'clock. This is nuts. Call them again. Side effect, don't worry. Third day, 2:30. I get this headache on the side of my head, above my ears, on both sides. That, unlike anything I've ever had in my life. Like, oh my gosh. And it was blinding. It hurt. Contact the COVID line again. Don't worry. Side effect. Headache was gone. Fourth day, I felt fine. No side effects. Nothing. Oh, sweet. It ran its course. Stirrups better. Friday, 2:30. I get these aches in my neck and my shoulders and about 3/4 of the way up my back, where like I couldn't like pick something up. It hurt so bad. Called the nurse's line. Hey, nothing happened yesterday, but today is this side effect. Saturday, the aches have now moved down to my pelvic region. It was hard to walk. Call the nurse's line. Side effect. You're fine. Still had this weird headache that would show up too. Sunday, the aches have now moved down to my knees and my feet. And that really hurt to walk. Call the nurse's line. Side effect. Monday, huge snowstorm comes through. We are now on spring break. Remember that snowstorm that happened in spring break? I'm usually the neighbor because I know I can't usually get to my gym on the snowy days, so I choose to exercise outside. I usually take care of my driveway out in front of and I have a couple of older neighbors that I shovel out their driveway and clear. That's just me. That's who I am. I put in my earbuds and enjoy it. I couldn't even go outside. I couldn't walk. A bad headache again. So this is bad. Tuesday, I finally get a doctor appointment. Describe to the doctor what's going on. So I've been contacting the nurse's line. They pull up the national registry. They can see all of the things that I had the whole time. Nurse looks at me. She goes, "You got COVID." Oh, this is fun. I wish they would have told me that, being I spent 5 days before spring break at school with COVID, and they kept telling me side effects. So, I don't know, kind of goofy. But again, that was all new. Now, if this COVID thing continues to happen, they're going to get more and more data. Now, we got a lot of data since, past year and a half. A lot of information. We have a lot of data that we're collecting still with vaccines. Okay, you can go on to cdc.gov and you can pull up all the information about every drug you've ever taken, any vaccine you've ever taken. You see everything about it. which is kind of nerdy to do, but it's also kind of cool to do. And I'm not somebody, I am a proponent of vaccines. But I got to tell you, I was like probably most of you, if you chose to get the vaccine, you're probably a little nervous about it, but you're like, ah. And of course, somebody might have posted some on social media, which you then believe. I don't know. So, you want a negative residual value. Let's see. On page 167, in this regression equation, is this regression a good fit for the data? Explain how you'd know. So this is from 93 to 2013, teen smoking rate and adult smoking rate. So it looks like from 93 to 2013, teens probably dropped the smoking. I believe this is tobacco smoking, not other smoking. And it actually looks like adults have decreased in smoking as well. So you could easily plug this into your calculator. You can create a regression model. But remember, a negative R value is not bad. If that negative R value is close to -1, that's good. That just means you have a negative slope. If you plug it into your calculator and your R value is positive, that means you have a positive slope. Okay, you want your regression models to be as close to +1 or as close to -1 as possible. And then with that information, so if I were to plug that data in, it's kind of weird to plug in 93, 95, 97, 99. Then you'd have to go 101, 103, 105, 107, 109, 111, 113, and then you can predict 120. And then would you trust the predictions? I haven't plugged it in yet. Okay? But again, so on Thursday, we're going to have a quiz that does some of this stuff. You will have some of this on calculator. If you need help on the calculator, it's okay. Okay? You're not disappointing me if you can't remember, the 77 different buttons we pushed in order to get something. Okay? I just want you to start feeling comfortable saying, my goal is by the end of this school year, you feel comfortable that there is a device that you could use in a future statistics class if you ever have to take one that will be very helpful, very useful for you. Okay? So your quiz is 2.6 to 2.9. You can use the note card. You can use multiple note cards. And then you can use a calculator. Hey, some of you, answer me this question. Have some of you gone down to just borrow a calculator from Math Science Resource Room? Has anyone done that in here? Because I think they have some. I know I have 8 calculators, which sometimes it's like all of a sudden there's 12 kids that need a calculator and there's 8 that are out. And it's like, sorry, you didn't get here fast enough. I don't like that. But I'm pretty sure you can just show your student ID at the Math Science Resource Room and get, the graphing calculator. Okay? So that's what we have. Tomorrow, do you guys even show up for school as seniors? No. Did you want me to call any of you when I get to school? Just make sure you woke up. Hey, I'm here, Stirrup. Hate you. So, we all good?